Hello student. In the last lecture, we have seen that exact differential equation and two problems. This is the part 2 for the exact differential equation. Let us see some example on exact differential equation. Okay. Now, the problem is solve dy by dx equals to y plus 1 upon y plus 2 into e raised to y minus x. Right. Okay. Now, let us write in mdx plus ndy form equals to 0. Now, first to write given differential equation into mdx plus ndy is equals to 0 form, right? Okay. Now, as dy equals to dx is equals to y plus 1, y plus 2 e raised to y minus x, we can write it as y plus 2 e raised to y minus x dy is equals to y plus 1 dx, right? So this implies y plus 1 dx minus y plus 2 e raised to y minus x dy is equals to 0. If we multiply this minus sign inside, then it is y plus 1 dx plus x minus y plus 2 e raised to y dy is equals to 0. Now compare with m dx plus n dy is equals to 0. So this implies what is m? It is y plus 1. And what is n? X minus y plus 2 e raised to y. Right. Now, after getting this format, m dx plus n dy is equals to 0, we have to check that the given differential equation is exact or not. For this, we need the dou m by dou y and dou n by dou x. Okay. Now, so this implies dou m by dou y means m ka partial derivative with respect to y. So it is 1, and dou n by dou x, that means n ka partial derivative with respect to x. Okay. So this is equals to 1. So this implies dou m by dou y is equals to dou n by dou x. So this implies given differential equation is exact. Given differential equation is exact. And 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 we know that and we know that solution for exact differential equation is integration m dx y treating as a constant plus integration terms free from x in n dy is equals to some constant c. This is the solution for the exact differential equation, correct? So this implies y constant. What is m here? What is m? M is y plus 1, correct? It is y plus 1 dx, y treated as a constant, plus integration terms free from x in n. Okay, n is x minus y plus 2 e raised to y. So we have to neglect this x because we need the terms free from x. So it is minus y plus 2 e raised to y dy is equals to some constant c. Right? Okay. Now, so y treated as a constant. So this is y into x plus x. Correct? Okay. Now minus integration of y plus 2 e raised to y dy. Right? Dy is equals to c. Now we can use here Leibniz rule. What is the Leibniz rule here? Suppose if we consider this is as u and this is as a v, then we have a formula. What is that formula? Integration u into v dx is same as u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on, where dashes 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 denotes derivative and suffixes denotes integration. Okay, this is the Leibniz rule. Okay, now so this implies yx plus x minus so this is u. According to the formula, we have to write it as u as it is. Y plus 2 into v1. That means e raised to y ka integration e raised to y minus u dash. That means y plus 2 ka derivative is 1 into v2. v2 means v1 ka integration. So e raised to y ka integration is e raised to y plus u double dash. That means u dash ka derivative 1 ka derivative is 0. v3 that means v2 ka integration. So it is e raised to y and minus 0 e raised to y and so on. Right? Because after some terms u ka derivative is 0, that means all term will get vanished after this. Right? So this is equals to c. So we can write it as x y x minus y plus 2 e raised to y minus minus plus e raised to y is equals to c. Right? Okay. Now, so this is equals to x plus yx minus y e raised to y e raised to y minus 2 e raised to y 2 e raised to y plus e raised to y plus e raised to y is equals to some constant c. So x plus yx minus y e raised to y minus 2 plus 1, it is e raised to, sorry, it is minus e raised to y, it is minus e raised to y is equals to some constant c. So if we take the x common, so it is y plus 1. If we take e raised to y constant, so e raised to minus y plus 1 is equals to c. So this implies y plus 1 x minus e raised to y is equals to some constant c. So this is the solution of given differential equation. What is that? dy by dx is equals to y plus 1 upon y plus 2 e raised to y minus x. Right? Okay. Now this is the example number 3. Let us see the example number 4. Okay. What is the example number 4? Solve x square minus x tan inverse tan square y plus x square y dy is equals to tan y minus 2xy minus y dx. Okay. Now, when we see this type of equation, just convert the equation into to write equation in form m dx plus n dy is equals to 0, right? So we can write this tan y minus 2xy minus y dx minus x square minus x tan square y plus sec square y dy is equals to 0. We can write it as tan y as it is minus 2xy minus y dx. Now plus, if you multiply minus sign inside, then it is x tan in square y, because minus minus plus, and then minus x square and minus sec square y dy is equals to 0. Now compare with m dx plus n dy is equals to 0, right? So what is m here? M is tan y minus 2xy minus y, and n is x tan square y minus x square minus sec square y, right? Okay. Now, we need dou m by dou y. So dou m by dou y is, what is tan square y ka derivative with respect to y? It is sec square y minus 2xy ka derivative with respect to y. It is 2x and it is minus 1. So we know that sec square minus 1, it is tan square y. So it is tan square y minus 2x dou m by dou y. Now, what is the reason here? Since 1 plus tan square theta is equals to sec square theta. Correct? Okay. Now, we need the dou n by dou x. So dou n by dou x, that means n ka partial derivative with respect to x. So it is tan square y minus 2x, and it is free from x, so it is 0. So look at the dou m by dou y and dou n by dou x. So this implies dou m by dou y is equals to dou n by dou x. So this implies given differential equation is exact. Correct? We know that we know that solution for exact differential equation. What is the solution for the exact differential equation? Integration m dx, treating y as a constant plus terms free from x in n dy is equals to c, right? So integration y constant. What is m here? Look at the m. Tan y minus 2xy minus y. Tan y minus 2xy minus y minus y. Okay. Dx plus integration. Now terms free from x in n. Now look at the n. This contains term x. So we will eliminate this. terms of x, that means we have to neglect this. Now just on remaining is minus x square y. So just we have to write minus x square y dy is equals to some c. So tan y as it is, tan y 1 ka integration, it is x minus 2y constant. What is x ka integration? X square by 2 minus y constant. 1 ka integration is x. Now minus sec square ka integration is tan y is equals to c. So it is equals to x tan y, x tan y minus x square y minus xy minus tan y is equals to c is the solution of given differential equation. Correct? This is the solution of given differential equation. X square minus x tan square y plus sec square y dy is equals to tan y minus 2xy minus y dx. I hope you understood. Thank you.